Years of Zoom teaching now. Okay, so thank you so much for having me. Drew and Guy gave a great sort of segue into what I'm going to talk about, which is some of the work that we've been doing in association with the coastal program, really all about trying to understand where that sand is going once we have erosion and what we can sort of learn in terms of resilience planning from understanding where that sand is moving. And the focus of the talk and the focus of our work really comes down to answering a question that probably a lot of you, if you're managing beaches, want to know, which is, will our beaches come back after a high phase of lake level? And if they do, how quickly? And are we going to get it back, the same way that it looked prior to lake level rising? And certainly, you probably have some indication that now, because of armoring or changes in the water level fluctuation rate, that this may be more challenging than just assuming we're always getting our beach back the way we had it. And so the focus of our work has been really trying to understand where that sediment goes. That's kind of the first step in all of this, is being able to track that, understand why it did what it did, and then use that to make some predictions. So my work is largely related to understanding, being the change on the coastline and using that to predict what might happen in the future. And there's really sort of two ways that sand move in the coastal zone. The first way is something you're probably familiar with through the Leadership Academy, which is longshore transport or littoral transport. And that's sand moving along the shoreline. That's what we hear about when we talk about sand getting trapped up in a harbor structure and maybe depleting sand from other areas, sort of downdrift of that. But sand can also move in the cross-shore direction. It can move back onto the beach, or it can move away from the beach. And Guy's example just a minute ago, where we talked about all that sand moving further offshore, is a great example of cross-shore sediment transport. So that's what we're really trying to document, is which pathway for any given site will that sand take? And knowing that gives us a way of indicating future resilience. Will the sand sort of stay out just offshore, which then it can kind of move back once lake level drops? Or is it sort of moved quickly away from the site, or maybe really far offshore? As to what might happen in the future. And all of that stuff changes based on what the site looks like. And so we're looking at a bunch of different sites. Geography matters. So thinking about what way the site is oriented in terms of those winds and waves that Guy just talked about, how much sand is actually at the site, and then what kind of armoring, what kind of structures do we have? Do we have a harbor structure? Do we have a large revetment? Which way are the prevailing winds? All of that stuff is going to change how that material actually moves, and we need to understand that, and then also understand how that relates to how the sediment is actually moving, if we're going to get to being able to tell you all the kind of information you probably want to know about how your site might behave moving forward. So for our project, we're looking at a range of sites throughout Lake Michigan and Lake Huron that sort of typify the types of coastal sites we have in this region. And so the first thing we need to do is we need to go out and map the coast and understand sort of what the coast looks like. So here on the left, you're seeing an example of just a mapped area of the nearshore and the beach. But then if we do that over enough time, we can actually look at erosion and accretion patterns. And that gives us an indication of how the coast is changing. So you can see the map here on the right shows you the red areas where sand's eroding, and the blue areas are where sand is accreting. And we're going to talk here in a second about what those patterns might tell us about resilience. So in order to make those maps, we have to go out in the field and generate those data. So we actually use drones to do most of our mapping of the beach and dunes. And so we fly these drones and we basically generate a sequence of images. So we can take these images and then back in the computer lab, end up actually stitching them all together. And when you stitch them together, you end up with data, millions of data points that we can then use to generate maps of the coast. So this picture you're looking at looks like a picture, but it's actually 29 million data points of what the elevation of the beach looks like on that day. So we can generate all kinds of products from this. So we can get nice pictures that we can then sort of link in with the stuff that Guy talked about with the historical aerial photography. But then we can also get actual models and maps of the beach, sort of shape and geometry from time to time. And so the beach portion is important. That certainly tells us sort of where the sand or how much sand is getting eroded away. It's a part that most of us really care about. But we want to know where that sand went. So we actually have to go out in the lake and start picking it up and tracking it. So we use a couple of different techniques for that. So we'll use a boat, or we'll also use remotely operated vehicles. So things with sonar attached to them where we stand on the shoreline and are actually able to map it. And you see, we still have a gap. So in the area where there's a lot of change happening, both of these techniques actually can't map it. So we have to physically get in there and map the area. So this is very sort of field intensive work, but what we end up with is a full three-dimensional picture of what the beach and nearshore actually looks like. So now we can really start to evaluate where that sand is going. And it allows us to say, hey, the sand left here and it went here. And that tells us something about where, where that sand's going, why it did that, and then what the actual processes are sort of moving forward and what that might mean for sort of managing that area. And again, the red are areas of erosion and blue are areas of deposition. So now I want to show you sort of some of the data products that we've generated from this and what they actually mean. And I'm going to start with like the best case scenario. I think the scenario that all of us hope happens once lake level starts to come back up. And so this is the ideal scenario. It's an area that's up in the thumb of Michigan, Port Crescent State Park. It has very minimal armoring. It's in the middle of sort of a coastal embayment. But we still saw lots of erosion as lake level came up. So we lost about 20 meters of our dune. We had lots of erosion of the actual foredune area. So you can see all of this red area here. But all of this material just went and it sat offshore in these sandbars. And so when you actually do the math, you can see the gain of sand in the nearshore is about 18,000 cubic meters. The loss was about 13,000. That's pretty balanced. And so this is a place where, and you can actually see it when you sort of slice it another way, you can see that that material that was actually eroding really just kind of went offshore and created new bars and kind of filled in holes in the lake. And so this is your like ideal scenario. Yeah, you've lost the beach and the dune temporarily, but that sand is sitting offshore. And as lake level falls, this is a place where we would think there's a lot of potential for that material to make its way back on the beach and grow the dune and grow those beaches again. There's minimal armoring to sort of, impact that. So this is a very natural system, very, high resilience capacity. Let's look at another example from South Haven. So we've mapped this area over time. And the first thing that we see with this is that this is an area, so if we're looking at 2012 to 2021, so this is during the rising lake level period, we see sort of a typical pattern for a harbor structure. This blue area indicates that we have sand sort of accreting on the updrift side of the harbor. And we think that a lot of that sand's coming from the erosion north of that area, a very similar pattern that we see all up and down the coast. However, you can see that this actually starts to wrap around the harbor structure. And some of it's actually sort of making its way back towards the beach on the south side. So this is a place where you're trapping some sand, but you are able to move some of it. So maybe not as bad as you would expect for some harbor structures. It's not trapping everything. Some of it can move away. But then we actually went out over the last year and mapped this again, and you're starting to see a lot of erosion in the nearshore during a period when we actually saw lake level dropping. So this is kind of interesting and gives us an insight into the dynamics of these fluctuating lake levels and what they do with sand, because essentially the faucet has been turned off for that sediment updrift of South Haven. So basically, we don't have as much erosion of the beach and dunes, so the nearshore isn't getting as much sand. So what we're doing is we're actually sort of reworking the material that's in that area right now, and it's sort of making its way through the system. So this gives us a really nice indication of what we sort of might expect as lake level starts to drop. We hope that that material starts to maybe make its way back on to the beaches. Now, another example where we think where there's pretty low potential for recovery is an area offshore of Saugatuck. So Saugatuck has had a lot of lake bed erosion, and this is partly because that area is a bluff area, so there's less sand in the system to begin with in a lot of these places, but there's also been extensive armoring along this shoreline. And so you can see the very dark areas of red are areas where the lake bed has been scoured out. And so those places, you're going to have to really bring in a lot of sediment from the littoral drift to start filling that area back in before you actually get the beaches to redevelop. However, there are pockets where the erosion is less, and even some places where we actually see accretion. So one of the things that we're sort of looking at is going in and taking some of those data that Guy has on the bluff retreat, and then some of the data that NOAA have about shoreline armoring, and trying to really understand sort of local scale connections between where the sand's going and what that sort of shoreline actually looks like. But by and large, in these places where we have lots of armoring and we have minimal sand and bluff erosion, we think this is an area where there's low potential for recovery. And so with that, I would just like to thank the sort of large hosts of students that work in my lab group, technicians that are out actually collecting the data. A lot of this work I'm doing in collaboration with Guy, lots of other projects I'm doing in collaboration with Dr. Norton, and then, of course, Eagle and NOAA for funding this work. This is really an exciting sort of next step in trying to put some of these forecasting pieces together and understanding